This list of steps is called the order of operations. It's an example of an algorithm, which is a set of step-by-step instructions to accomplish a goal or solve a problem. This particular algorithm is designed to help you simplify expressions. But we use algorithms in other places besides math class too. When in your life have you followed step-by-step instructions before? Maybe you followed the steps of a recipe, or you followed the instructions to help you play a game. Why was it important to follow those instructions carefully? What do you think would have happened if you accidentally skipped a step, or you did the steps out of order? Yeah, especially in a recipe, if you skip a step and you forgot to put something in, it probably is not going to taste very good, right? Pretty yucky, or at least not how you meant it to taste. And then with a game, sometimes if you do things out of order, they start to not make sense and things aren't very fun, right? So usually it really helps to follow instructions carefully and in order. So we actually have a CT practice that's all about that, following instructions carefully. It's the algorithms practice. So when we're using algorithms, we're developing and using systematic, step-by-step approaches to problems. That word systematic comes from the word system, which is just a set of parts or components that work together to accomplish a task or solve a problem. So we call algorithms systematic approaches because there's a set of steps that all work together to help you solve a problem. So that's why it's important to follow them carefully, because they're designed to work together. So we already found an example of why it's important and helpful to have algorithms in math. Remember earlier when we were talking about simplifying this expression, and when we didn't have the order of operations, we got different answers, didn't we? Some of us thought this expression should simplify to 42 because we did the addition first. So we thought 3 plus 4 is 7, and 7 times 6 is 42. So this expression is equal to 42. But then there were others of us who did the multiplication first and said, well, wait, 4 times 6 is 24, plus 3 more is 27. So this expression is worth 27. But once we had the order of operations, we knew what order we were supposed to do things in, and it was helpful to make sure we all got the same answer when there were different possible answers. So that's one way algorithms can be really helpful, and why it's helpful to follow the steps carefully when we have an algorithm. But even when algorithms are really clear and spell out the steps really carefully, a lot of the times we still have to do careful thinking when we're following them to make sure we're thinking about how the step applies to our specific problem. And sometimes we might even find there are steps that don't apply. So like, for example, I'm thinking about a recipe that I use to make a cake. We said a recipe is an example of an algorithm. And this recipe, at one point, it tells me to add 2 cups of sugar to the batter. And that seems pretty clear. You know, it's pretty clear what I have to do, but it doesn't tell me where in my kitchen I have to find my sugar. And it doesn't tell me what bowl I put the batter in. Those are things I had to figure out for myself for my particular cake. And then I'm thinking about last time I made this cake, I got all the way down to the bottom and there were steps at the end about making my own frosting. I didn't really want to make the frosting. I already had bought some frosting that I was going to use. So I thought to myself, you know what, for this cake, these steps don't apply. I'm not going to do that. So it's the same kind of thinking we might have to do when we use math algorithms to help us solve math problems. So let's just practice what that kind of thinking might look like when we use the order of operations to simplify this expression. So what's the first step of our algorithm? Work within parentheses. Okay, so how does this step apply to our problem, this expression? I don't see any parentheses, do you? So this step doesn't apply. We can just move on. The next step says to write numbers written with exponents in standard form. Does this one apply for this problem, this expression? Nope, I don't think so either. I don't see any exponents, so I think this one doesn't apply either. So we can move on. The next step says do all multiplication and division in order from left to right. Does this step apply to our expression? Yes. Well, how do you know? How can you tell? Yeah, we see this multiplication sign, right? That tells us that there is multiplication to do. And because it's between this 4 and this 6, we know that those are the numbers we need to multiply in this case. So we can say, okay, we know 4 times 6 is 24, and let's just write that down so we know we've done it. Now, the step said do all multiplication and division in order from left to right. Is there any more multiplication or division we need to do? Not in this case, right? I don't see any more. So I think we can move on. Do all addition and subtraction in order from left to right. Does this step apply to our problem? Yeah, she knew I was going to ask, how do you know? So she said yes, because we have that plus sign, and it's between the 3 and the 24. So we know that's the addition we need to do. So 3 plus 24 is 27. Now, do we have any more addition and subtraction to do? No, we're down to just one number. So I think we're done. So that's an example of how we can be really careful when we're following an algorithm and think carefully about each step. You're going to get a lot of practice today applying the order of operations algorithm to a lot of different expressions. Later in the year, we're also going to practice developing algorithms or writing them ourselves. So we're going to think about what steps we can use to solve problems and then practice writing them down in a way that helps other people follow them. But for today, we're just going to get lots of practice applying the order of operations algorithm.